In this video, we're going to take a look at rate of change, which is just an application of slope. So if you haven't previously watched our video on how to calculate slope, I would suggest you do that first and then come back and look at rate of change. A rate of change compares a change in one quantity to a change in another. So we're comparing two quantities. Slope is a rate of change comparing the change of vertical to horizontal as we move from left to right when we read a graph. The slope formula is y2 minus y1 over x2 minus x1. We want to think of slope as a set of ordered pairs that we're finding the difference of, and the same thing for rate of change. These are mostly application problems, so word problems. The table to the right shows the distance a person walks for exercise. Find the rate of change in distance with respect to time. In the word problem, they say find the rate of change in distance with respect to time. So when we set up our fraction, we're looking for the change in distance over the change in time. And the way the word problem is set up, distance comes first, that's on top. Time is on the bottom. The other thing you should know when we're talking about rate of change, time is always an element that will be on the bottom. It is an x value. When we look at our table, time represents the x value, distance represents the y value. And when we take a look at our slope formula, remember the y value goes on top. So when I'm looking at this, I'm looking for a change in the distance over the change in time. And in our last video, we took a look at a table of values and said we could pick any two ordered pairs from the table. So for super ease and getting rid of decimals, I'm going to choose the first and the last set of ordered pairs. So I'm going to call this one ordered pair 2, this one ordered pair 1. And that refers to the y2 and the y1, x2, x1 in my formula. So I'm going to take a look. I'm going to do the distance first, the change in y's. So that would be 4.5 minus 1.5 over 90 minus 30. 4.5 minus 1.5 is 3, and 90 minus 30 is 60. I can simplify it even further. 3 goes into 3 one time. 3 goes into 60 20 times. So what is it that this fraction represents? It means that we can travel, our rate of change is 1 mile per 20 minutes. Make note of, because this is a word problem, we need to go ahead and go a little bit further. It's 1 mile in 20 minutes, but you know what? I don't want to know how far I can go in 20 minutes. I want to know how far I can go in 1 minute. So I want to keep dividing, and here I would suggest using a calculator to go ahead and divide top by bottom. So if we divide 1 divided by 20, we get 0.05 miles. That's how far we can go in 1 minute. And that's the rate we're looking for. Think of it almost as a unit rate in terms of 1 minute rather than 20 minutes. You can, go 1 mile in 20 minutes, but how far can you go in just 1 minute? That's what we're looking for. We can go 0.05 miles in a minute. Take a look at our next real-world example. A community theater performed a play each Saturday evening for 10 consecutive weeks. The graph shows the attendance for the performances in week 1, 4, 6, and 10. Describe the rate of change in attendance with respect to time. So here's my word problem again. Attendance with respect to time. So attendance over time. And if I look at my graph here, yeah, attendance is along the y-axis and time, week of performance, is on the x-axis. So we'll go ahead and take a look at weeks 1 and 4. So here's week 1, that's ordered pair 1, and up here is week 4. So I'm going to do 232 minus 124 over 4 minus 1. 232 minus 124 is 108. So again, that's telling me that we're increasing attendance by 108 people each week, but I want to know per 1 week. So I'm going to go ahead and do this division. I'm going to do 108 divided by 3. And I'm going to get 36. And what does that represent? People per week, per 1 week. Per is another representation of that fraction bar or division. Okay, when I take a look from weeks 4 to 6, and I'm going to go ahead and erase my markings here. New set of ordered pairs. Week 4, that's going to be ordered pair 1, and week 6 is ordered pair 2. If you notice, there's a slight decrease. My slope is slowly decreasing. It's negative. Let's see what that means. So I'm going to have 204 minus 232 over 6 minus 4. 6 minus 4 is 2. And when we do 204 minus 232, we do get a negative. We get a negative 28. And we can go ahead and again, we don't want to know the drop in attendance per 2 weeks. We want to know the drop per 1 week. So we're going to go ahead and divide. And we'll get a drop of negative 14 people over 1 week. And you might just want to say, you know, this is a drop of 14 people per week. Drop is indicating that decrease or that negative value. All right, let's take a look at the next one, week 6 to week 10. So again, I'm going to erase this. This looks like even more of a decrease. Wow, check that out. All right, this is ordered pair 1. This is going to be ordered pair 2 for me. So I have 72 minus 204 over 10 minus 6. I know on the bottom I have 4. And let's see, when I do 72 minus 204, we have a drop, a change of negative 132. Again, we don't want to know how many people are decreasing in attendance every 4 weeks. We want to know every 1 week. So we're going to go ahead and divide that by 4. And we're going to get a negative 33 people per 1 week. Or you can say, you know, a drop in attendance of 33 people per 1 week. So this is using a coordinate grid in conjunction with the word problem to find the rate of change. And again, we always want that 1 on the bottom when we're talking about rate of change, not particularly with just a slope problem, finding the slope of a line, but when we are applying it to a rate of change, we do 1 per 1 value in the bottom. A missile is 2 miles above the Earth in 60 seconds after launch and 6 miles above the Earth in 3 minutes. What is the rocket's rate of change in miles per minute? So they're telling us how to set up our word problem. Miles over minutes. And we already know that because we know that time, any element of time, should be on the bottom when we're talking about range. So I'm going to go ahead and take a look at my sentence again. A missile is 2 miles above the Earth in 60 seconds. So 2 miles goes with 60 seconds. 60 seconds is my time element. So that's going to be the x value, and the 2 miles is going to be the y value. In my second statement, I have 6 miles above the earth in 3 minutes. So I have 6 miles above the earth in 3 minutes. Notice that my measurement in time is in seconds and in minutes. So when I look at my question, it says miles per minute. So that means I need to change the 60 seconds into minutes. And luckily for us, that works out nicely because 60 seconds is equivalent to 1 minute. Now that I have my 2 ordered pairs from my word problem, I'm going to go ahead and put it into my rate of change. y2 minus y1, so 6 minus 2 over 3 minus 1. 6 minus 2 is 4 miles in 2 minutes. But again, we don't want to know how far you can go in 2 minutes. We want to know how far you can go in 1 minute. So 4 divided by 2 is just 2. The missile can travel 2 miles per, whoops, I put week there, minute, per 1 minute. And if you just wrote per minute, that represents 1. Great job. All right, I'd like you to go ahead and find the slope of the given point. So this is just practice of slope. So we'll pause the video, calculate, and we'll check back in just a minute. Take a look at your answers. We have for letter A, our slope is 3 over 1, or 3. For letter B, this is undefined. When we had a 0 in the denominator, we can't divide by 0, and this is undefined. For letter C, notice when we subtracted, we got a -2 over -3. You can simplify those negative signs, and you should. -2 divided by -3 is 2/3. And lastly, for letter D, I have a 0 in the numerator. We can divide 0 by something, and when we do, we just get 0. Letter A, our graph would look something like this. Letter B would be a vertical line up and down. Letter C would be a negative sloping line. Oh, nope, I'm sorry, it's also positive. So that's also this way. And then a 0 slope would be flat as can be. Find the rate of change in calories with respect to time. Calories with respect to time. So calories is the y value, time is the x value, and you just pick 2 that you want to work with. I'm going to pick this ordered pair and that ordered pair, so those numbers look easy for me. So I've got 1,000 minus 500 over 80 minus 40. We get 500 over 40. We can go ahead and reduce, or we can go ahead and grab our calculator and go ahead and divide right away. We'll get 500 divided by 40 will give us 12.5. And what does that represent? Calories per 1 minute. These are word problems. They require words in your answers. Don't forget those tags. Marvin started a savings account with $100. After 5 weeks, he had $150. After 10 weeks, he had $200. What's the rate of change of money in his savings account per week? So this is going to be money over weeks. There are 3 sets of ordered pairs here. He starts his account with $100. So that's going to be a 0 start with $100. That's 1 ordered pair. 5 weeks, $150, and so on and so forth. 10 weeks, $200. So you pick the 2 ordered pairs that you want to go with. I'm going to go with the easy ones. I'm going to say 200 minus 100 over 10 minus 0. We'll get 100 over 10. When we divide 100 by 10, we get 10. And what does that represent? $10 per week. Remember that slope is a ratio, vertical change over horizontal change, y2 minus y1. Slope can be analyzed